Many of the analysis that we do make assumptions that our data are normally distributed. So we need to check that our data are correctly recorded and that they do follow a normal distribution. There's a number of arithmetical and graphical checks that you can make, but first of all, it's best to check that the data on your computer match the data you collected in your records. Then check that your data follow the normal distribution. Compare different measures of central tendency, for example, the mean, the median, and the mode. And then look at the shape of the distribution and evaluate how variable it is.
So first off, our definition of the mean, which we call x bar, and this equals the sum of the individual values that we've measured divided by the number of observations.
Now the median is the middle value when our observations are ranked from lowest to highest. And if we take the first example here, we've got 5 values ranging from 20 to 28, and the middle value, the median, is 25.
When we look at the second list of data, we see that we've got an even number of observations, which means that we have 2 middle values, one of 25 and one of 26. When we have an even number of observations, the median value is given as the average of those 2 middle values, so 25.5 in this example.
The mode is the value with the most number of observations. So if we look at our normal distribution here, the mode is the one with the highest frequency.
As a rule of thumb, if data is normally distributed, then the mean will equal the median and also the mode.
Okay. Now sometimes we find values which are way out of line. They're extreme values that are very improbable. And sometimes these are very obvious. You might have put the decimal point in the wrong place.
Or you might have even stood on the weigh scales.
Marginal values are actually difficult to assess.
Here we have an example where we have what we call a right-hand skew. The data aren't normally distributed. We have some very extreme values which are well out on the right-hand side of the distribution. If we work out the mean, we will find that it's to the right of the median. In other words, the mean is very much affected by these very large values, but the median remains the middle value and remains unaffected by them.
Similarly, you can actually have a left-hand skew. Okay, so in this distribution here, we've got the distribution affected by some very small values. And in this case, the mean is much smaller than the median.
Another deviation from the normal distribution is something that we call kurtosis. This means that you have a high peak, as in the example on the left, and you lose observations from the shoulder of the distribution. In the example on the right, you've got a flattened distribution, where observations are put onto the shoulders from the peak.